Good day everyone. Again, this is Sir Will Bansuela Jr. from SDOQC New Era High School. So welcome to our Math Kwentuhan with Sir G. Another math lesson to be discussed. So without further ado, join me again. Okay. So just like what we did on our math lessons or our previous math videos, no? We start our discussion by getting all our lesson goals. So in today's lesson goals, for number one, you are going to, or after this topic, you can define infinite geometric series. Alright? So on our previous lesson, we've discussed the finite geometric series. Now this is just a continuation of geometric series, guys. So this time we're going to focus on infinite. So it has no boundary, no? So mamaya, we're going to deal with that, no? And for number two, of course, you are going to solve problems involving infinite geometric series. And here are our goals. Okay? Alright, so let's define the infinite geometric series. So infinite geometric series is the sum of an infinite geometric sequence. Again, an infinite geometric sequence doesn't have an ending. So, just like if you could remember on our discussion in finite geometric series, you are asked there to solve for the sum of 7, sum of 9, sum of 10. So we have a definite particular total sum of number of terms to solve, no, in a finite sequence. So that is a finite. But this time, in infinite geometric series, we don't have a particular ending. That's why it is called infinite, no? Ayan. So it has no definite ending. If it has, then we are dealing with finite geometric series. Alright? Okay. So to show that in figure, so if you could notice the triangle here will go along that way. Even we don't see it, it will push through, no? Tuloy-tuloy lang siya dyan. So ganyan yung infinite series, no? Or sequence, just like this one, no? Tuloy-tuloy lang yan. So yan yung ibig sabihin ng infinite or infinity. Ayan, ha? So yan yun. Pero if it has an ending, then that particular sequence is a finite series or sequence. Okay? Okay. So let's discuss the formula for the sum of infinite geometric series. Again, if you could notice, we have the infinity sign. So the sum of infinity sign is equal to the first term, of course, a sub 1, all over 1 minus r, or your common ratio. But you have to take note that r should not be equal to 1, simply because if r is equal to 1, so 1 minus 1 will turn into 0. So therefore, if your denominator is equal to 0, the entire equation is undefined. So that's why r should not be equal to 0. So what do we expect? R, for us to have a sum, alright, you have to take note of this, guys. For us to have a sum, your common ratio must be greater than negative 1 but less than 1. So this is the only range for the value of r, or your common ratio, for us to have a sum. But of course, if your common ratio is less than negative 1 but greater than 1, so we are going to declare that that particular problem has no sum. Alright? So you have to take note of this. So therefore, guys, before solving, before we use the following given and plug in it to our formula, so we have to take note of the common ratio muna. So if the common ratio of a particular given series is less than negative 1 and greater than 1, then we don't need to do that anymore. We don't need to use the formula to solve pa, because we can no longer, or we can always say, or we can conclude that that particular given has no sum. Alright? Okay? So if it satisfies this condition. Alright, it has no sum if the common ratio is less than -1 but greater than 1. But it has a sum if the common ratio is greater than -1 but less than 1. Alright, so for you to understand it well, let us have some exercises. But before that, so let's determine all the elements of this formula. Alright, so take note again, this is the sum of infinity or sum of the terms. So we have no definite number of terms dyan because this is infinity. Of course, a sub 1 is first term and your r is your common ratio. Alright, so let's try to solve problem. Okay, let's find the sum of the infinite geometric sequence to -8, 32. So again, our first move is to identify all the given. Alright, so we have the first term which is 2 and the common ratio is -4. So 32 divided by -8 is -4. -8 divided by 2 is -4. Now, if you could notice, -4 is less than -1, right? Because -1 is the highest negative integer. So, therefore, -4 is less than -1. So, if that happens, we are going to declare that this infinite geometric series has no sum because the common ratio, which is less than -1, has no sum. Again, take note. So we are not going to solve anymore using the infinite geometric series formula because our common ratio is less than -1. Okay, so take note of that. Okay, again, if you have some confusion dealing with this problem, you may always pause the video, then rewind, okay? Then you check the rules a while ago. Please do a screenshot or you may copy that in your notebook para you have a basis for your conclusion. Okay? Alright. Okay. So let's proceed on our next problem. So our next problem, so find the sum of an infinite geometric sequence 9, 3, and 1. Okay, just like what we did on our first problem. So we identify the first element which is 9. And this time we are going to get as well the common ratio by dividing the last value, alright, on the right towards to its left. So 1 divided by 3, that is 1/3. Then 3 divided by 9, again, that is also 1/3. So the givens are a is equal to 9 or a sub 1 equals to 9 rather. The first term is 9 and the common ratio is 1/3. Now what can you say about the common ratio? Alright, correct. Our common ratio is less than 1. So therefore, alright, therefore, it has a sum. So every time that the common ratio is less than 1, it has a sum. So therefore, we can continue using the formula. Alright, so we can plug in all the given 9 for the first term and 1/3 for the r. Then let's use the formula. We can find the sum. Alright, so let's do that. So we will arrive at a sum of infinity equals to your first term is 9 divided by 1 minus your common ratio which is 1/3. So 1 minus 1/3, simplifying that, we will arrive at 2/3. Then simplifying 9 all over 2/3. So 9 times 3, that is equal to 27. Then just copy 2. So therefore, the sum of this infinite geometric sequence 9, 3, and 1 is 27 all over 2. Again, take note, we can only have a sum if the common ratio is less than 1 and greater than -1. Okay. So let's try to solve another problem. Okay, so here we go. So let's find the specified unknown. So So find the unknown. If the sum of the infinite geometric series is 45 and the first term is 15, so let's find the common ratio. Alright, so this is simple plugging in the given to your formula. Alright, so let's take the pattern or formula. The sum of infinite geometric series is always equal to the first term divided by 1 minus the common ratio. So, let's plug in. The sum of infinite series is 45. So, we change this by 45. And your first term is 15. And r will remain r. So, we don't know it yet for a while. So, let's do that. Okay. Then, we will arrive at 45 equals to 15 all over 1 minus r. Okay. So, our objective here is to isolate r. So, we can do that by multiplying 1 minus r to 45. So, what is left on the other side is 15. So, we will arrive just like this. Okay, so we multiply these two. Then, using a distributive property of multiplication, so multiply 45 by 1 and put 45 by negative r, we will arrive at 45 minus 45r. So, and that is equal to 15. Then let's isolate r. So if you could notice, we have a negative value beside r. So I might suggest we transfer negative 45 on the right side and we transfer as well 15 to the left side. Then we will arrive at 45 minus 15. Again, take note, when we transfer one term from one side to another, we have to change the sign. And if you could notice, negative 45, after transferring that on the right side, it turns out to be positive. Then let's simplify. So 45 minus 15 gives us 30, and that is equal to 45r. Now, last two steps, guys. So we have to eliminate 45 beside r. So let's isolate that by a division property. So let's divide the entire equation by 45. Then we will arrive at r equals to 30 over 45. And simplifying this fraction, alright, then we will arrive at r equals to 2/3. So therefore, we can say, in this particular problem, our common ratio is 2/3. So tama lang, guys, no? Yung common ratio natin dito is less than 1. That's why we have a sum of 45. So take note, magkakaroon lang tayo ng sum ng infinite geometric series if the common ratio is less than 1 and greater than negative 1. So yun lang. If it's not, then we can declare that the given problem has no sum. Alright? Okay, again, if you have some confusions with this solution, you may always pause the video, guys, rewind, rewatch, then you try to solve using your pen and paper, guys. Again, mathematics is a pen and paper skill. I advise you to practice and do it in a couple of times. So 5 times, I'm sure mamamaster na ninyo yung skill na to, no? So don't hesitate to use your pen and paper. I'm sure you will get this and you will master the skill. Okay? Alright. So with that, so I want you to get your pen and paper, guys. So let's practice. So it's your turn to solve some problems, guys. Again, you are advised to pause the video after you see the given problems. No, you may pause the video for 10 to 15 minutes before you play this video, so that you have time to solve your own problem. So don't just look for the final answer, no, or the correct final answer. So our goal here is to know how to arrive on the final answer or on your final correct answer. So that's what's yun yung pinaka importante sa lahat, guys, no? Ayan, no? Kailangan alam natin kung paano nag-arrive on the final answer. Alright, so let's proceed. Okay, so for letter A, let's find the sum of the following infinite geometric series. For number 1, 16, 8, 4, 2. And for number 2, we have 64, 16, 4. And for letter B, let's find the unknown. So for number 3, if the sum of infinite geometric series is 28 and its common ratio is 1/7, let's find the first term. Ayan. So we simply plug in all these values using your formula, no? So simple lang yung letter B. And for number 4, our final question, if the sum of the infinite geometric series is negative 36 and the first term is negative 60, let's find the common ratio. Ayan. So, again, please pause this video for 15 minutes before playing it again to check your answer if it is correct. Alright? Sige. Alright, so your 15 minutes is up. Then we are now ready to check your paper. So, let's see if your answers are correct. Alright, so let's deal with that. Okay, so for number 1, the sum of the series is 32. Alright, for number 2, the sum of the series is 256 all over 3. For number 3, the unknown first term is equal to 24. And for number 4, final number, the common ratio in that particular series is negative 2 terms. Alright? So I hope you got all these answers correct. But if not, don't feel bad. You may always review, no? You may always pause this video, rewind, then relearn, rewatch, no? You try to solve it again until you don't need this answer key anymore, because you know how to arrive on the following correct answer. Again, our main objective is to know how to arrive on your final correct answer. Alright, with that, again, I say thank you. I will say you are the best, guys. Again, practice lang tayo lagi. Alright, so until our next Math 21, guys, again, this is your Math Guru Sir Hill saying be safe. Good day, everyone.